If integration by substitution was similar to the chain rule, integration by parts is similar to the product rule. The product rule you used when y equals uv, right? So the integration by parts is going to be the same. It's when inside your integral, you're going to have a function with uv on the inside. Now, in order to do this, we're going to change this up a little bit. There's a certain formula which you're going to use. The formula for integration by parts looks like this. Your integral is going to have u and dv by dx with respect to dx. This is going to be equal to uv minus the integral of v du by dx with respect to dx. That's the integration by parts rule. This you have to know, and the more you do it, the more it's just going to stick, really. Let's have a look at a question in practice. So in this case, you have x cos x. Now, we said the start of the formula was u dv by dx, right? And then you have blah, blah, blah. So this x is your u, and cos x is your dv by dx. When we went through differentiation, and we went through the product rule before, I labeled out u and then du by dx, v and then dv by dx. Same thing is going to happen here. So u equals x, dv by dx equals cos x. So that means du by dx is 1, and that's done by differentiation. V is going to be sine x, and that's done by integration. Now that I have all the parameters, I can now plug into the second part, or the right hand side of the integration by parts formula. So it went uv minus integral of v du by dx. So u x v sine x minus the integral of v sine x times du by dx, 1 dx. This is all equal to I, which is my integral. Okay, from here, simplifying this would give that. And now we just have to integrate sine x, which would be minus cos x. X sine x minus cos x would give plus cos x plus c. Done. There you go. That is integration by parts. You literally just have to use the formula. Same with the product rule. You work out your parameters, stick it in the formula. So, this question. Now, we have x squared, and then we have ln x. According to the example we did before, we would have made this u and this dv by dx, right? Here's the issue with that. There's no rule to integrate ln x. There is a rule to differentiate it. There isn't a rule to integrate it. So I would suggest swap these around. Make this u and make this dv by dx. That is possible. You can choose. Majority of the time, you're going to stick with the normal arrangement. So where u comes first and then dv by dx comes after. But in some cases, that's not possible. So you switch it. I would say most of the time, try and stick to the normal arrangement of a u first. In this case, like I said, not possible. You don't have any other choice. Make u equal to ln x. So if u equals ln x, then du by dx is 1 over x, and dv by dx is x squared. So v is x cubed all over 3. Cool. Now you're ready to stick it in the formula. U v minus integral of v times du by dx. Like this. So x cubed over 3 ln x minus integral of x squared over 3 dx, which means you get x cubed over 3 ln x minus x cubed over 9 plus c. Done. I hope that made sense. I want you to try these 2 questions for me, please. Okay, first one. U is equal to x and dv by dx is equal to cos 4x. So du by dx is just 1 and v is a quarter sine 4x. So x over 4 sine 4x minus integral of 1 over 4 sine 4x times by 1, which is just that. And after integrating that, you should get x over 4 sine 4x plus 1 over 16 cos 4x plus c. You can take it a step further and factorize out the 1 over 16, but not really necessary. Okay, that's that one. B. Use your answer to part A to find the other one. You don't really need to use it, to be honest. I would just do it from scratch, really. U equals x squared. dv by dx is sine 4x. du by dx therefore would be 2x, and v would be minus a quarter of cos 4x. Cool? Now, minus x squared over 4 cos 4x minus integral of minus 1 over 4 cos 4x times 2x dx. Do you see how there's a negative here and a negative here? We can therefore just make this positive. Okay. After integrating, you would get this. Uh, 1 over 32, 4x sine 4x plus cos 4x plus c. To go from here to here, you would have the integral of x over 2 cos 4x dx, which would be the same as a half of x cos 4x dx. Now, from here, you can apply parts again, and then put it back in to this. So u equals x, dv by dx equals cos 4x. So du by dx equals 1, and v would equal 1 over 4 sine 4x. Now, x over 4 sine 4x minus the integral of 1 over 4 sine 4x dx, and then x over 4 sine 4x minus or plus 1 over 16 cos 4x plus c. That is this here. That's what you had at the end of part A. So you had to do integration by parts twice. So from here, you would have, if I didn't look at the mark scheme, which admittedly I was, which is the only reason I got this, you would have that there. That would be your answer. If you left it like this, I would say that's okay. You don't necessarily have to do the whole simplification. I would personally just leave it like this. If you can simplify, by all means. But yeah, have to do integration by parts twice. That's not uncommon. There are plenty of times where you're going to have to do parts more than one time in the same question. They do that just to throw you off. They do that to make your life longer, for you to get confused, because remember, they don't want you to get it right. They don't want you to get the mark. Or at least that's how I think about it. They make things difficult just to be annoying like that. So if you end up in that scenario where you have to do, or you think you need to do integration by parts twice, that's fine. If you think you need to do it, you probably need to do it. But yeah, that is integration by parts.